Greetings, dear learners. Welcome to the official YouTube channel of SRN International School, Jaipur, Rajasthan. I am Faculty of Chemistry at SRN International School. Today, in this video, I will be explaining Unit 3, Chapter Electrochemistry for Grade 12 Chemistry, NCERT. Electrochemistry. It is the study of relationship between electricity and chemical reactions. It is the study of production of electricity from the energy released during spontaneous chemical reactions and the use of electrical energy to bring about the non-spontaneous chemical transformations. So here, the type of reaction that is taking place is the redox reaction. It is oxidation as well as reduction reactions taking place simultaneously. Electrons, they are transformed from one species, which is a reducing agent, to another species, which is an oxidizing agent. So this transfer of electrons, it provides a means for converting chemical energy to electrical energy or electrical energy being converted to chemical energy. Electrochemical cells. It is an apparatus that is used to generate electricity from a spontaneous redox reactions and or it uses electricity to drive a non-spontaneous redox reaction. So there are two types of electrochemical cells, galvanic cells or voltaic cells, and second is electrolytic cells. Galvanic cells are those cells which uses the energy released during a spontaneous redox reaction to generate electricity. Spontaneous redox reactions are the reactions that takes place on its own. And in that case, the Gibbs energy change is negative. Electrolytic cells are those cells which consumes electrical energy from an external source using it to cause a non-spontaneous redox reaction. Non-spontaneous redox reactions are the ones which are only taking place when electrical energy is supplied to it. In that case, the Gibbs energy change is positive. So this is a particular galvanic cell which is made up of two half cells, which is shown by a beaker. On the left hand side, we have a copper rod dipped in copper sulfate solution or say copper nitrate solution, and the other half cell, which acts as a cathode, has a silver electrode dipped in silver nitrate solution. When these two half cells, that is the two electrodes, anode and cathode, when they are connected by a wire through a voltmeter, then the electron will start flowing from anode towards cathode. Thus, there will be a flow of current because by convention, current flows in the opposite direction to the direction of the flow of the electron. So thus, current will flow from cathode towards anode, and thus the circuit is complete. And this is shown by the value that is appearing on the voltmeter, 0.460 volt. There is a salt bridge also shown here, which is made up of a strong electrolyte like potassium nitrate. So nitrate ions moves towards anode because copper plus 2 ions are collected over there, and on the right hand side, that is at cathode, the nitrate ions are collected, so that has to be neutralized by K plus ions of the potassium nitrate. Thus, the whole circuit is complete. Daniel cell is another example of galvanic cell. Daniel cell is made up of two half cells, anode made up of zinc rod in zinc sulfate solution and cathode copper rod with a copper sulfate solution. At anode, there is an oxidation taking place of zinc to form zinc plus 2 ions by removal of 2 electrons, and therefore the zinc rod will have negative charge because of the collection of electrons. At cathode, the reduction is occurring where the copper plus 2 ions from the solution accepts 2 electrons to form copper. Thus, when the two half cells are connected by a wire, then electron will start flowing from anode towards cathode, and thus current goes from cathode towards anode, and the circuit is complete. Salt bridge is also shown here. The function of the salt bridge is to neutralize the solution and secondly to complete the circuit. Galvanic cells are of two types, primary cell and secondary cell. Primary cells are the batteries that is designed to be used once and discarded and not recharged with electricity. The electrochemical reaction that occurs in such type of cells is not reversible, rendering the cell unrechargeable. Whereas secondary cells are a type of electrical batteries which can be charged, discharged into a load and then recharged many times. Leclanche cell. Leclanche cell is an example of primary cell. These are also called as dry cell, and these cells are used in the torch, wall clock, etc. So this is made up of carbon rod, that is graphite rod, which acts as a cathode. It is surrounded by a mixture of manganese dioxide and powdered carbon, and there is a paste of ammonium chloride. It is surrounded by a cardboard case on sides only, but inside this there is a container which is made up of zinc. This zinc container acts as an anode. Now, if you consider the whole cell, so there is a wax seal above and below, but some part is left, so that zinc container is exposed, because zinc container here acts as an anode. So zinc is negatively charged and the carbon rod, that is graphite rod, is positively charged. Now when it is connected by a wire through a bulb, then electron starts flowing from anode towards cathode, and thus current flows in opposite direction. The zinc in the zinc, which acts as an anode, is actually getting oxidized to form zinc plus 2 ions and 2 electrons. So when zinc plus 2 ions goes into the ammonium paste, then it forms a complex, which is therefore this, and the ammonia gas that is evolved is also there inside the cell, and this ammonium gas reacts with zinc to form that complex. The voltage of this Leclanche cell is 1.5 volt. Mercury cell is another example of galvanic cell, and it is a primary cell. So mercury cell is used in the hearing aids. It's a small button shaped cell. It is actually made up of zinc mercury amalgam, which acts as an anode, and a paste of HgO and carbon acts as a cathode. The electrolyte here is the paste of potassium hydroxide and zinc oxide. They produce constant voltage of 1.35 volt during the discharge. At anode, the zinc reacts with OH minus ion of KOH electrolyte to form zinc oxide, water, and 2 electrons are evolved. At cathode, the 2 electrons are accepted by mercury oxide and water to form mercury and OH minus ions. So net reaction is that zinc amalgam reacts with mercuric oxide to form zinc oxide and mercury. Lead storage battery. It is a secondary cell and it can be recharged after it gets discharged. So this lead storage battery is also called as car batteries, and it is made up of 3 cells, 3 electrochemical cells. If you consider one cell, then it is made up of anode and cathode. Anode is a lead plate packed with spongy lead, and the cathode is the lead plate packed with lead dioxide, PbO2. Now there are all the anodes, they commonly join together to give a common anode that is negatively charged, and all the cathodes give a common cathode as a positively charged. So when the reaction takes place and the cell is working, after some time when the battery is dead, that means then we find that on the anode and cathode some white precipitate is formed, and this is actually lead sulfate formed on the anode and cathode. Now this battery is then connected to recharger. So when it is connected to recharger, then all the lead sulfate and on the anode and cathode, it gets dissolves into the electrolyte till the H2SO4 comes to 38%, and thus the battery is recharged and it can be reused. Fuel cells. They are the galvanic cells which are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into electrical energy. One of the most useful fuel cells is by using the reaction of hydrogen and oxygen gas to form water. The cell was used by the Apollo space program for providing electrical power. So here in this fuel cell, hydrogen gas and oxygen gas is bubbled through the porous carbon electrode, which is embedded by the catalyst, that is metals like platinum or palladium, so that it can increase the rate of the reaction. When these hydrogen and oxygen are passing through the porous carbon rods, then they react with the concentrated aqueous solution of potassium hydroxide. So then at anode, the oxidation reaction occurs where the hydrogen gas reacts with OH minus of KOH solution to form water by removing 4 electrons. And then at cathode, the oxygen accepts 4 electrons in presence of water to form OH minus ions. And thus the circuit is completed and the electricity is produced. The advantage of the fuel cell is that when this cell will run continuously as long as the reactants are supplied. Secondly, it is a pollution free, and thirdly, it increases the efficiency of the fuel cell. Dear students, I hope you must have understood this topic. Keep learning, keep exploring. Thanks for watching. Please like, share and subscribe to our channel for more informative videos.